Saturn. The second largest planet in the solar system after Jupiter, Saturn is located 6 planets from the Sun. With a typical radius of almost 9.5 times that of Earth, it is a gas giant. Saturn is nearly 95 times more massive than Earth, but having only an eighth of the average density. A core of iron, nickel, and rock undoubtedly makes up the majority of Saturn's interior, silicon and oxygen compounds. Its outer layer is made up of gas, followed by a deep layer of metallic hydrogen, an intermediate layer of liquid hydrogen, and a layer of liquid helium. Saturn's upper atmosphere contains ammonia crystals, which give the planet a faint yellow tint. It is hypothesized that Saturn's planetary magnetic field, which is weaker than Earth's yet has a magnetic moment 580 times that of Earth due to Saturn's bigger size, is created by an electrical current within the metallic hydrogen layer. The magnetic field strength of Saturn is roughly 1/20th that of Jupiter. Although long-lived structures can be seen, the outer atmosphere is typically monotonous and lacking in contrast. Saturn's wind speed limit is 1,800 kilometers per hour, which is higher than Jupiter's but lower than Neptune's. The planet's large ring system, which is primarily made up of ice particles with a little amount of rocky debris and dust, is its most distinctive characteristic. There are hundreds of moonlets in Saturn's rings, as well as at least 83 confirmed moons orbiting the planet, 53 of which have official names. The only moon in the solar system with a significant atmosphere is Titan, Saturn's largest moon and the second largest in the solar system. Titan is larger than the planet Mercury despite being less massive. Physical characteristics. The main components of the gas giant Saturn are hydrogen and helium. Although it lacks a clearly defined surface, it probably has a sturdy core. Due to its spin, Saturn is an oblate spheroid, meaning that its equator bulges and its poles are flattened. The distance between its equatorial and polar radii, 60,268 kilometers against 54,364 kilometers, is over 10%. The other giant planets in the solar system, Jupiter, Uranus, and Neptune, are similarly oblate, albeit to a lower degree. Because of the bulge and rotation rate, the effective surface gravity near the equator, 8.96 meters per square second, is 74% lower than the surface gravity of Earth and is lower than that at the poles. The equatorial escape velocity, which is almost 36 kilometers per second, is significantly higher than the Earth's. The only planet in the solar system with a density around 30% lower than water is Saturn. Despite having a core that is far denser than water, Saturn's atmosphere causes its average specific density, which is 0.69 g/cm3, to be lower than that of water. Saturn is 95 times as massive as Earth, while Jupiter is 318 times as massive. Saturn and Jupiter make up 92% of the solar system's total planetary mass. Even though hydrogen and helium make up the majority of Saturn's mass, most of it is not in the gas phase due to the fact that hydrogen becomes a non-ideal liquid when its density exceeds 0.01 g/cm3, which is attained at a radius where 99.9% of Saturn's mass is concentrated. Saturn's interior experiences a steady increase in temperature, pressure, and density as it moves closer to its core, turning hydrogen into a metal in the uppermost layers. According to conventional planetary models, Saturn's interior resembles Jupiter's, with a small rocky core encircled by hydrogen and helium and containing minute amounts of various volatiles. Saturn is far more centrally condensed than Jupiter, and as a result, the area around its center contains a significantly greater amount of material denser than hydrogen, according to analysis of the distortion. By mass, Jupiter's center regions have about 67% hydrogen and Saturn's central regions have about 50% hydrogen. The composition of this core is comparable to that of the Earth, although it is denser. Physical intermodels and analysis of Saturn's gravitational moment have made it possible to set limits on the mass of Saturn's core. According to calculations made in 2004, the core must be 9 to 22 times the mass of the Earth and have a diameter of around 25,000 kilometers. Saturn's rings measurements, however, point to a far more diffuse core with a mass of about 17 Earths and a radius of roughly 60% of Saturn's total radius. A thicker liquid metallic hydrogen layer surrounds it, followed by a layer of helium-saturated molecular hydrogen that progressively turns gaseous as altitude rises. Gas makes up the 1,000 km long outermost layer. Saturn emits 2.5 times more energy into space than it receives from the Sun and has a heated interior that reaches 11,700 degrees Celsius at its core. The Kelvin-Helmholtz mechanism of slow gravitational compression produces Jupiter's thermal energy. However, because Saturn is less massive than Jupiter, this mechanism could not be enough to explain how heat is produced there. A different or additional process for producing heat could be the raining out of helium droplets from deep inside Saturn. The mechanism causes friction to produce heat as the droplets move through the lower density hydrogen, depleting the helium in Saturn's outer layers in the process. It's possible that these falling droplets gather to form a helium shell around the core. Diamond rain has been hypothesized to fall on Saturn, Jupiter, Uranus, and Neptune, as well as the ice giants Uranus and Neptune. Planetary rings. The system of planetary rings that gives Saturn its distinctive appearance is arguably what makes it most well known. The rings have an average thickness of 20 meters and are located between 6,630 and 120,700 kilometers from Saturn's equator. They are mostly made of water ice, with minute amounts of tholin impurities and a 7% amorphous carbon covering sprinkled on top. The ring's constituent particles can be as little as a dust particle or as large as 10 meters. The ring systems of the other gas giants are also present, although Saturn's are the biggest and clearest. Regarding the genesis of the rings, there are two basic theories. One theory is that the rings represent the remains of a destroyed Saturnian moon. The second possibility is that Saturn developed the rings from the original nebula material that was used to create it. The Moon and Enceladus geysers are responsible for some of the ice in the E-ring. The outermost ring A has the purest frozen water, while the water abundance of the rings varies radially. The variation in abundance could be attributed to meteor bombardment. The sparse Phoebe ring is located 12 million kilometers from the planet, beyond the main rings. Like Phoebe, it orbits retrogradely and is tipped at a 27 degrees angle to the other rings. Some of Saturn's moons, such as Pandora and Prometheus, serve as shepherd moons to keep the rings in check and stop them from dispersing. Strong, linear density waves that Pan and Atlas produce in Saturn's rings have allowed for more accurate calculations of their masses. Observation. The four other planets that can be seen with the unaided eye from Earth are Mercury, Venus, Mars, and Jupiter. Saturn is the planet that is the farthest distant from us. Uranus and 4 Vesta can occasionally be seen with the unaided eye under dark skies. With the unaided eye, Saturn appears as a brilliant, yellowish point of light in the night sky. Saturn's apparent magnitude is 0.46 on average, with a 0.34 standard deviation. The ring system's inclination with respect to the Sun and Earth is the primary cause of the magnitude variation. When the ring's plane is inclined most steeply, they are at their brightest magnitude, 0.55, and at their weakest magnitude, 1.17, respectively. With the zodiacal constellations as a backdrop, it takes the planet around 29.5 years to complete one full cycle of the ecliptic. The majority of people will need an optical tool, extremely big binoculars, or a small telescope that magnifies by at least 30 times in order to obtain a clear image of Saturn's rings. The rings are so thin that they briefly vanish from view when Earth travels across the ring plane, which happens twice per Saturnian year, about every 15 Earth years. The following such disappearance won't be visible to observers until 2025 because Saturn will be too close to the Sun. When Saturn is at, or close to, opposition, when a planet is at an elongation of 180 degrees and appears opposite the Sun in the sky, it is easiest to observe Saturn and its rings. Every year, or roughly every 378 days, there is a Saturnian opposition, which causes the planet to be at its brightest. Because both the Earth and Saturn have eccentric orbits around the Sun, their separations from the Sun and from one another change over time. As a result, Saturn's brightness varies from one opposition to the next. When the rings are tilted to be more visible, Saturn also appears brighter. For instance, even though Saturn was closer to the Earth and Sun in late 2003, it looked to be at its brightest at the opposition on December 17, 2002 due to the advantageous orientation of its rings in relation to the Earth. Saturn is occasionally obscured by the Moon, that is, the Moon covers up Saturn in the sky. Occultations of Saturn take place in seasons, just like those of the other planets in the solar system. Monthly Saturnian occultations will occur for roughly a year, followed by a 5-year interval when no such activity is seen. Occultations only happen when Saturn is close to one of the points in the sky where the two planes intersect. Both the length of Saturn's year and the 18.6 Earth-year nodal precession period of the Moon's orbit influence the periodicity. This is because the Moon's orbit is inclined by several degrees with respect to Saturn's orbit.